Hi everyone, this is a video about collision damage prevention system for vehicles that can prevent body damage for vehicles as well as life forms. Uh, Collision damage prevention in cars. So this is a simple model of a car, and uh, there is a collision damage device that is uh, built in under the car, inside the car, and it pops up when the car is about to collide something and saves the car from damage. And this is a collision damage prevention system for cars in in the side direction. When the collision takes place uh, in the side of the car. So generally, vehicles have airbags, so passenger gets affected. Passengers don't get injured. So this is a system where um, the vehicle itself is protected from damage. So this is a collision damage prevention system for trains. This is a normal train without any collision damage prevention system. The collision damage prevention system is below the train. It can be in front of the train as well, and it gets deployed when the train when there is when the driver senses there is going to be damage to the vehicle. So this is again image-based explanation for collision damage prevention for cars. So this is a car, and there is a device buried under the car, uh, and it gets deployed when the driver senses that uh, there is going to be some accident, and this is the extended version of uh, the collision damage system, and it uh, when it is fully stretched, and in the middle image it is preventively deployed, and in the final image the damage to the vehicle will be far less. So collision damage prevention systems for cars. This is example design one. This is a front view of the system when it is deployed. This is a top view of the system when it is deployed. This is side view of the system when it is deployed. And there are two possible frameworks for the side view deployment. Collision damage prevention system for cars. Example design 2. This is the front of the vehicle, and this is top of the vehicle, and this is side of the vehicle. So in this case, uh, there are two frames that are placed one behind the other. So the the collision can take away damage to the system. Uh, this is collision damage prevention system for cars. E- Example design 3. This is the front view, um, and this is the top view, and this is the side view. So in this case, there is a protrusion uh, along the extended framework itself. So the when you hit the protrusion, the extended framework can sufficiently bend and take uh, the impact load. You will understand the design philosophy in the later slides. Collision damage prevention system for cars. Example design 4. this is this is a front view of the car, and this is another front view of the car, and uh, this is a wireframe design of of the front view with two different types of wiring connecting the rods. Collision frame before and after impact. Before impact, top view, front view. Uh, this is before impact and this is after impact. So the object might be here, and the framework has collapsed, and uh, and um, it has taken the energy of the collision. Front view. This is a front view, and with a different framework, and the top view of the same framework uh, when it is under collision, when it undergoes collision. So before framework, before impact, this is a front view of two different orientations. Uh, After impact, this after impact. This is the framework. Uh, the lowermost frame is continuous. The ro- upper frames get twisted and turned. Uh, in the in the in the wired system, the wires get extended, and the framework might have a final appearance like this. So this is before and after. Uh, these twisting rods might have uh, magnetic or uh, elastic or fluid based uh, restoration mechanism. Collision damage prevention for trains. Train with installed collision damage prevention system. Train with deployed collision damage prevention system in case of emergency. This is the collision damage. This is the previous. This is after. This is after collision damage prevention system. Collision damage prevention system. Two-way horizontal. So this is one framework, and this is the second framework. Uh, so this the first is two-way horizontal swing doors. The intermediate region is the collision object trapping region, and this is one-way. The bottom of the framework has one-way vertical swing doors, uh, and the later half one-way horizontal swing doors. Collision damage prevention for trains. Side view. This is a side view, and this is a top view. Uh, there are two possible frameworks for the side view which have been shown, and for one of the side views, two possible frame top view arrangements are shown, where in one case the rods are longer and another case rods are shorter. So during collision, this is the collision framework. Uh, During collision, the rods get displaced in one direction, and this is the side view of the rods and elastic system, there is a one-way twist, and the top view is displayed here, where the intermediate region, where the rods are twisted in two orientations, and the intermediate region might actually trap the object. So this is the final side view when the rods are twisted in one direction in front of the vehicle, in when the vertical rods are in the front, and another direction of the vertical rods are in the back, and there is a rods that are displaced downwards to carry the load of the object that is trapped in between. So this is again a system for trains. A person might run into a train, or a vehicle might run into a train, and this is done to prevent collision. This is a mathematical representation of the system. Uh, this is one object that is going to collide with another object that is which has a prevention system. Uh, there is a spring apparatus, and this is a energy absorbing apparatus, and a energy providing system to restore the spring if it is needed. So this is the velocity and energy during collision process. This is the velocity, relative velocity, and this is time. Relative velocity goes down with time as the colliding object loses its velocity and comes to a lower velocity, or it comes to a stop with respect to the moving object. Uh, this is the energy representation of the collision apparatus. Uh, the dotted lines show the uh, potential energy of the system, collision apparatus system. The collision apparatus system, it accumulate energy and dissipate energy, accumulate energy, dissipate energy, accumulate energy, dissipate energy. Uh, and So as the object dissipates, as the collision apparatus dissipates energy, it has to be restored to its original form. So energy is given into the collision apparatus. This is a collision energy boosting curve for uh, the same uh, system where energy is given and energy is lost. So in the bottom of the curve, there are two different uh, collision processes that have been explained. And the lower system, the energy is lost at a lower rate and energy is given to the system at a lower rate. This is for objects that are more fragile, that can break easily. So by Newton's law, change in change in kinetic change in velocity by time is the force. So for a constant time, a object that can withstand less force um, will lose has to lose kinetic energy at a lower rate, uh, and the slope of velocity to time curve has to be different. So final thoughts on this presentation: the spring model of collision damping is unlikely to work as relative velocity goes to zero. So I've shown you a presentation and I am saying it may not work exactly the way it is supposed to. The point I'm trying to make is that when a spring compresses and expands, its its velocity at one of the points goes to zero. So this happens even during one oscillation of the spring system. So when velocity goes to zero, the object has stopped already, but the spring model can still be used because it is better than the current available uh, models which are rigid frames. Spring model can be used in when the object goes undergoes one oscillation, it still loses energy. So acknowledgements. I want to acknowledge uh, Newton's classical mechanics for giving me these thoughts on how to solve the problem. And also want to thank automobile and train manufacturers uh, for 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 uh, their work and their contributions to my thoughts on this. So, final disclosure, the author does not know the originality of the idea or work presented, meaning whether it is an invention or reinvention or copied work. Any leads for the above stated point is appreciated. TBS, this is my new acronym. It stands for Thick Book Somewhere. Learned that TBS also stands for Turner Broadcasting Systems. Hurdles. Author could not present the PowerPoint theme. Design made the design software made some random changes and took his time. Request. Author is unemployed and any job offers will be appreciated. Where to submit the and another question is author has is whether author can submit the work in any paper and whether the watchers of the video have any thoughts. Thank you.